Hello student, good morning to all of you. Today we are going to discuss about the transverse nature of EM wave and its properties. Okay, and the spectrum of EM wave. First is transverse nature of EM wave. Okay, student, it is observed that we formed last day in the last lecture the EM wave are moving uh, EM wave in which electromagnetic vector, electric field vector and magnetic field vector are moving perpendicular to each other, and they are also moving perpendicular to the direction of propagation of wave, which we formed as like this. These are the electric field envelope, and these are magnetic field envelope of EM wave, in which we observe that the direction of wave and the wave is given by vector s. This vector s is called pointing vector, pointing vector, or we say propagation vector, propagation vector. We conclude that the electric field vector is given by E naught sine omega t minus kx, and we take here the initial phase phi, and the magnetic field vector B is equal to B naught sine omega t minus kx plus phi. Okay, where phi is the initial phase, because both the waves are moving mutually perpendicular and simultaneously. In EM wave, electric field vector vector E and magnetic field vector magnetic field vector B are moving mutually perpendicular to each other, each other and also perpendicular to direction of propagation of wave, direction of propagation of wave vector s. Hence, or we say therefore velocity of propagation vector, that is the propagation vector s is given by vector e cross vector b. Here student, vector b is magnetic field vector, and when the current is moving in a circuit, therefore charge is oscillating, which create the EM wave, that is the accelerated charge is creates EM wave. It is clear? Therefore जब चार्ज एक्सेलरेट होता है तो उस समय वो जो जिस मटेरियल से प्रोपगेट हो रहा होता है या फ्लो करता है, उस मटेरियल को मैग्नेटाइज करता है. मैग्नेटाइज के लिए हम यूज करते हैं एक सिंबल कैपिटल एच. हियर एच इज मैग्नेटाइजिंग फील्ड, मैग्नेटाइजिंग इंटेंसिटी भी बोल सकते हैं, मैग्नेटाइजिंग इंटेंसिटी. तो इसको यूज करके जो पॉइंटिंग वेक्टर हमारा होता है, इट इज गिवन बाय वेक्टर ई क्रॉस वेक्टर एच. ये दो रिलेशन हमारे पास, एक मैग्नेटाइजिंग इंटेंसिटी के फॉर्म में और एक मैग्नेटिक फील्ड के फॉर्म में. देयरफॉर वी ऑब्जर्व दैट therefore it is observed that velocity of EM waves is given by the relation C is equal to E naught upon B naught and C is equal to 1 upon under root of mu naught upon epsilon naught. And by calculation Maxwell observed it, the value of C of EM wave is 3 into 10 to the power 8 meter per second. Hence he observed that the EM wave are transverse in nature. Therefore it is conclude that the EM waves are transverse in nature. So just copy this all. This is about the EM wave have transverse nature. Initially it is taken as the EM wave have the longitudinal nature, but Maxwell conclude that the EM wave has transverse in nature because they are moving. The formation of EM wave is the combined effect of electric field vector and magnetic field vector, in which the electric field vector and the magnetic field vector are mutually perpendicular to each other, and they are also perpendicular to the direction of propagating vector, or which is known as pointing vector. So the pointing vector is given by vector S is equal to E cross B, and here this is the cross product of electric field and magnetic field vector, and the result is also at the 90 degrees. So it is observed that the EM wave are the transverse is nature in nature, and the velocity of EM wave is confirmed that the EM wave has transverse nature because the velocity of EM wave is exactly equal to the speed of light, and it is also observed that the EM wave are not required any material medium to propagate. Okay, so if a wave or a energy wave is traveling without a material, so it is confirmed that it is a transverse nature or transverse wave. Okay, now we take some properties of EM wave, then we are going to spectrum of EM wave. Properties of EM wave. First one is EM wave is produced by EM wave is produced by accelerated charge, accelerated or oscillating charge. In the circuit. Second, EM waves are transverse in nature as the electric field vector and magnetic field vector are mutually perpendicular to perpendicular to each other and also perpendicular to perpendicular to direction of propagation of wave, that is vector S is equal to vector E cross vector B, and C is E upon B or 1 upon mu naught upon epsilon naught. Third, EM waves carry energy and as well as momentum. That is, energy of EM wave is given by mc square, where m is mass of particle, and c speed of light, or we say EM wave. Therefore E is equal to mc into c. Okay, therefore this E will become P into C, because momentum is mass into velocity. Therefore we calculate here, the momentum is E upon C, and student, we have E is equal to h nu upon C. Therefore we have nu is equal to C upon lambda. So we calculate momentum is h c upon c lambda. Here this c is cancelled and we get finally the momentum is h upon lambda. This is where h is Planck constant, Planck's constant, and lambda is wavelength of EM wave. Okay, copy this. Okay, here students, in place of E we can also use U equal to P into C. So we get P is equal to U upon C, where U is energy density. In last lecture we discussed about the energy density, which is the U. Okay, next we have fourth property. EM wave are neutral in nature. EM wave are neutral in nature, hence they are not deflected by electric and magnetic field. Okay, next, energy density of EM waves is given by energy per unit volume. Energy per unit volume and per unit time in direction of in direction of propagation is remain constant and equally divided in electric field and magnetic field, that is average energy density UE equal to UB, okay, and UE is equal to half epsilon naught E square and UB equal to half B square upon mu naught. Hence the energy of EM wave is UE plus UB is equal to half epsilon naught E square plus B square upon mu naught. By taking LCM, we find that okay, इतना ही छोड़ देते हैं because it is also perfect. This is the energy given by the EM wave in the direction of propagation, and the energy of EM wave is equally divided in electric and magnetic field vectors. नेक्स्ट इसमें हम लिख लेते हैं द सिक्स्थ प्रॉपर्टी, EM wave are shows the properties of properties like reflection, interference, diffraction, and polarization. Polarization property property shown by EM waves also prove that EM waves are transverse in nature. Okay, copy these next properties. Okay, next property is seventh. In EM wave, in EM waves, electric field vector E is responsible for optical effects or light effects. So it is also called light vector, which is given by vector S. Hence electric field vector carry energy in EM wave. So in EM wave, electric field vector carry energy. These are the properties of EM wave. Okay, student. In the next class, we take the electromagnetic wave spectrums. Thank you.